So today we're going to talk about inventory and production management and the implications that has to facilities design. Now I know most of you have taken 410 or are taking it right now, and so you are exposed to some of these issues, but I'm going to particularly talk about them as they relate to facilities design and just give you a touch of the kinds of things that you need to consider. So we're going to talk about types of inventory and how to plan for space requirements for that. Unit load issues, about how to think about the way that you move things around the facility. And then lastly, we're going to sort of touch on some issues around just-in-time inventory management systems. Now, again, I know you know this stuff and you've seen it before, but it's kind of a quick overview. Now, this is just a sort of a graphic of the different types of inventories in the systems. You need to plan for the purchase of the raw material and the holding of it until it's moved into processes. And that in each process, you need to think about the holding of the incoming and the outgoing material at each process. All of that is called work in process inventory, which needs to be managed and understood how it's working. So once you get past the work in process inventory, then there's going to be finished goods inventory, and that needs to be held until it's sold. So all through a facility, no matter if it's a production facility or if it's just a warehouse, you need to think about inventory in the processes in the various different kinds, from raw material, work in process, to finished goods. The next issue that I want to talk about is the unit load. So how are things moved around the facility? Are they moved one at a time? Are they put in a pallet? Are they in a tote? Are they in a box? Are they just one item? And it changes depending on where you are in the process, but really having a clear understanding of how the company thinks about the unit load is going to help you a lot when you're talking with the company and then also when you're planning. So you need to think about, really define what that is. Small unit loads increase transportation time. So if things are moved by one item, then you'll be going back and forth quite a lot. But large unit loads increase work in process. So if you have a whole, like if you actually are moving pallets around, then the amount of inventory that's going to be sitting in the facility at the time is going to be quite large. There's also limits associated with time, with the size of the item and the weight of the item. So thinking that through. This is just an example of one of the ways to think through the concept of unit load and batch size, or the batch size and the completion time. So in this case, if you see along the bottom, I have processing time at 1 minute on 2 machines, and then the transportation time is 2 minutes. Now this is just an example. It's sort of a little bit exaggerated example. But if you look up here, in this case, I'm processing a unit load of 16 at a time. And what that means is that you start at time period 0 and you process for 16 minutes, because there's 1 minute processing time. You process for 16 minutes that load, then you transport it for 2 minutes, and that's on the first machine you process it, transport it to the second machine, and then it's processed for another 16 minutes. So the total processing time then for this particular thing is 34 minutes. That's what that's indicating. And there's an average work in process, or the average work in process at each location is 16, because it's half. At this point it's 16, at this point it's 0. At this point it's 16, at this point it's 0. So that means it's average at 8. So that's just like a way of thinking about how much area you need to dedicate to work in process, the number of times you have to transport, and the total processing time. Now if we contrast that to a unit load of 8, in this case, we have it processed, you process 8 units on the machine, first machine, transport it, and then you process the next 8 unit for 8 minutes on the second machine. And then this is the second batch of 8, because you're processing a total of 16 to compare it to this unit processing. And then it's transported, and then you process it for another 8 minutes. So now what we've done is we have the unit load at 8. The average work in process is now 4, because it's 8 here and 0 here. And the number of transports is 2. So you can see these are 2 transports. The processing time actually was decreased a bit too. Now again, we're going to contrast that to a unit load of 2. So now what we're doing is we are processing for 2 minutes, then transporting it, and then processing for 2 minutes. So those 2 items are done. The next 2 items are processed, transport, and then run on the second machine. So you can see that what's happening here is the machine is busy all the time, the transportation is busy all the time, and the second machine is busy all the time. So the unit load of 2 gives us an average work in process of 1, because it's either 2 or 0, which is 1. The number of transports now, though, is 8, because we had to transport them all 16 units 2 at a time, but the processing time has decreased to 20. So now when we look at this, our question is, well, which is the optimum processing time? And that's actually going to be your question that you need to submit. Like, which is the optimum processing time? And actually, you don't have quite enough information to answer this question, but I think I really want you to say, well, how do we decide such a thing on optimum processing time? The next thing I want to look at is just pallets and container sizes. Just knowing when we talk about a pallet, there's all different kinds of pallets, and a pallet is not just one thing. This is sort of a random slide here, but it is something I want you to think about associated with unit loads. There's all different kinds of pallet sizes. When they see a pallet, it can be a variety of sizes. The height at which it can be stacked also varies depending on how heavy the things are and how stable the boxes are. Also, there's different types of pallets: wood, corrugated fiberglass, plastic, metal. Those issues they all have different usage. Most of them are wood, but wood has the drawback of possibly carrying more contaminants, insects, and dirt. So if it needs to be more of a clean area, you might go to fiberglass or metal or plastic. Also, the unit loads associated with pallets. Looking at stacking a pallet is also sort of an art in itself about how to stack the pallet up, how to make it stable. You don't just pile them all on top of each other. You actually have to interlock them. Also, looking at the different sizes of boxes and deciding which is the best to put on a particular pallet. So now we're going to move into a little bit more on just-in-time philosophy. Now, again, I know you know these things, but I'm trying to just refresh your memory. The issue of Kanbans, it really has to do with visibility and it has to do with communication. Kanban, the word Kanban actually means card, and it's really just an indicator that something needs to happen. A Kanban can be a light, or it can be a card, or it can be a signal that goes from one workstation to another. And most of you know how to do this, and it's a concept of like once something's done or something needs to be done, there's a way of signaling to the next place in the process or the previous place in the previous step in the process that something needs to happen. And it really is a matter of setting up those signals so that things don't just sit around not being processed. The next sort of just-in-time philosophy is simplicity. The idea that it's best to have a pull system where customer demand is the way that things are processed, that once a customer buys something, then that signals the process to move ahead and fill that particular location with a completed item. And that is a ripple effect all the way through the system. And ultimately, that also signals raw material to be started to be processed. So a complete pull system is really signaled through the customer, and that once a customer buys something, then that makes the system go. That's as opposed to a push system, where a push system, you produce things based on what you think the customer might do or based on a forecast. That's an MRP system, is pretty much a push process. You have a forecast that you have about customer demand, and you produce to do that. And you produce to put that on the shelf, you don't produce it for the customer. It's a little bit different philosophy. Most companies strive to be pull, but it's very difficult to be pull. Most companies are sort of a combination of both. Flexibility, the concept that if you can get to a place where you have a single unit production, that no matter what is being processed in the production line, whatever unit you get, you can process that. You don't have to do a changeover. Like you can process part 267, and then the next thing in the line can be 273. Those can be processed all one after another. That's opposed to batch production, where you process 10 or 100 or 1,000 of one particular process, and then you change over and you produce 1,000 or 5,000 of another particular product. That is a little bit more less flexible. So you'd want to be able to have a single unit production, but it all has to do with how short your setup times can be. If your setup or changeover from one product to another is long, then you're going to have big batch sizes. If you can change over instantaneously, then you can move to single unit production. And the idea is to try to move to single unit production. Again, it's not always possible, but that is the idea. Standardization of everything. So even the screws that you're using, that's why this little picture of a screw, no matter what it is, why have 10 different screws for fasteners? Why don't you just use the same one for everything. So the amount that you can standardize tools, standardize parts, standardize connectors, standardize processes is going to help a lot in just-in-time kinds of things. And then the last thing is there this 5S, which is also related to lean manufacturing, that a place for everything and everything in its place. And I've talked about that before, but that's definitely something you want to look at in all of your projects to try to think of ways to standardize some of the processes. This helps flexibility. It helps a lot having to do with increased awareness of what's going on. There's a couple other things here I have listed. Reduce the inventories, just-in-time impact on facilities design. So what does this do? If we implement just-in-time, what does it do to the facilities? Reduces inventory, deliveries to point of use. So now instead of delivering at sort of a central location, you deliver it right where it's needed. Quality at the source. So that means you're going to have to, if you're going to be checking quality, you need to have a footprint or a place where that's done. How are you going to do that? And it might mean that actually you get rid of a quality control department and you actually put quality inspections right in the assembly line. Better communication, line balancing, and multifunctional workers. So cell manufacturing might be something you want to do, looking at balancing the line and looking at flexible workers. More frequent delivery, smaller batch sizes. So the unit loads are going to be a little smaller and the transportation is going to be more often. So looking at what kind of material handling would support that would be part of it too. Smaller centralized storage, more decentralized storage. So you're not going to have one big inventory area, you're going to have several small ones. And the material handling is going to be for smaller, lighter loads. So maybe you'll have a conveyor belt instead of a forklift, those kinds of issues. Standard containers, trays, or pallets. Again, that standardization and also having to do with material handling. And then you'll also want to look at how can you best use barcoding and RFID. It's going to have space requirements should be reduced if you use just-in-time, smaller loads to be stored and moved, and storage requirements fall. That pretty much finishes up the inventory issue. These are slides that I always like to show, and because I'm not lecturing to you, I don't want to not show these to you because they're pretty funny. You might have already seen them before because I've shown them in other classes, but these are a series of slides of safety awards. So this particular award was given to this forklift operator that was using a forklift to lift things. This one actually cracks me up because that guy in the corner, he just makes me laugh that he's standing there looking so oblivious. This is another one, looking at a safety award to try to look at stringing a wire. This is especially good using electric cord hanging over a swimming pool on an electric ladder. And this is the winner of the award, that they are changing a light bulb. Pretty incredible.